The final and probably most difficult problem to solve is the planning and organization of what we will do with the genetically engineered offspring. In practical terms, how we will manage their growth, development and success. The scientists keep saying that their rescue mission goes far beyond the birth of the first thylacine joey. The ultimate goal, of course, is to begin reintroducing this lost keystone species, with the help of conservation organizations, to specific areas of Tasmania, and probably parts of mainland Australia, so that it can regain its vital role in the ecosystem. But there is still a long way to go. The first generation of Tasmanian tigers to be introduced will certainly not be ready for release into the wild. They will need to grow up in a controlled environment where scientists can continuously monitor their vital functions. As I mentioned earlier, there is a high chance that they will be quite fragile due to any deficiencies or developmental defects in certain organ systems, particularly the respiratory and circulatory system. But even if this shortens their lifespan, it will not be a total defeat for scientists, but an opportunity to see where the mistakes are and to correct them, possibly in the very next generation. It will probably take several generations before we get 100% healthy specimens suitable for reintroduction. But even that will not be the final victory. Even when, or if, the first Tasmanian tigers are released into the wild, they will need to be closely protected and monitored, at least in the early stages. Their uniqueness, origin and the investment that has gone into their creation will undoubtedly make them the most valuable creatures of the moment. They will need to be strongly protected from negative external influences, as well as possible threats in the form of poachers, until a sufficiently large and stable population can be established. An effective framework for achieving this goal requires hundreds of comprehensive plans, from establishing suitable breeding sites, to ensuring security conditions, setting up technology to help us monitor specimens, working closely with local governments, communities, numerous wildlife and ecosystem conservation organizations, and so on. As this involves a lot of complicated bureaucracy, obtaining various permits and, above all, the need for even more investment, things are moving rather slowly. Ordinary people often grumble about this, assuming that the process is being unnecessarily delayed, that too much is being hidden from us, and that we are basically being made fools of. In fact, we should be more tolerant and realize that something like the de-extinction of the thylacine has never been done before by scientists with any species, so slower and more cautious steps should be quite understandable to us. To conclude this video, I would like to talk to you about what we can learn from the process of the Tasmanian tiger's de-extinction and how we can benefit from the lessons we have learned. Surely the most important lesson is that genetic engineering cannot be our regular tool to solve the problem of continuing species extinction. We cannot rely on the fact that every animal that we wipe out of the world through selfish and reckless behavior can be quickly created in the laboratory. As we have seen in the case of the Tasmanian tiger, this is a lengthy and extremely demanding process, requiring enormous financial resources in addition to the scientific work, so we will not be able to afford it very often. We should therefore remember that protecting nature and wildlife from pollution, habitat loss, hunting and global warming is by far the most effective, economically viable and best way to combat mass extinction. So while we await the return of the superpredator to the old-growth forests of the Tasmanian wilderness, let us first and foremost ensure that in the meantime we do not put any more stress on the environment and cause another of its remarkable endemic animals to disappear and be doomed whether or not we decide to bring it back to life.